In this video, we are going to talk about derivatives. So just we continue our previous lessons. So we know that the derivative generally is denoted as dy by dx, or you can also say y prime. So and then let us say that we have a function y equal to x to the power n, so such that n is not equal to 0. Then we say that dy by dx, that will be equal, so what we do, we multiply by n, and then x we subtract 1, so n minus 1. So this is a main rule of derivative that we will apply. So an example, let us say that, just example, maybe we call it example 1. So let us say that we have this function y is equal to 2x cubed plus radical x plus x to the power, for example, 2 divided by 3. And now we would like to find the derivative of this function. So what we want is dy by dx. So we say that dy by dx. So now we apply the rule. So we multiply 2 by 3, then we get 6. Or we can say, okay, here we multiply the 3 by the 2, and then x to the power 3 minus 1, then plus. Here we have, this is x to the power half. So that means we would have half. We multiply this by 1, x to the power half minus 1, and then plus again we multiply. Here the coefficient is 1, multiply 2 divided by 3, and then here we get x to the power 2 divided by 3 minus 1. And then here we get 6 x to the power 2 plus half x to the power minus half plus 2 divided by 3 x to the power negative third, because here we have 2 thirds minus 3 thirds, then we have negative 1 over 3. So this is a final answer for this function. So we start by symbol as usual, and then we introduce a bit more complex examples. So let us say example 2. So let us consider the following function. Let us say that we have this function x 1 plus 2x to the power 4, for example. Everything here is divided by x squared. So of course, if you are already familiar with derivatives, you can use a quotient, but here it is not needed. So what we would like to find is dy by dx. So this is what we want. So now we can rewrite this function in this form. We can say y is equal to x to the power negative 2. So we just bring this up, so it comes as negative, and then here we would have 1 plus 2x to the power 4. So then that will become x negative 2, because we need to distribute the multiplication here and here. When we multiply this by 1, then we get x as a negative 2, plus when we multiply this by x to the power 4, so we can do it step by step. So we multiply x negative 2 times x to the power 4. So now we know from the exponents, so we just write this again here, plus 2. So now we add negative 2 plus 4, which is 2. So that means this is x to the power 2. So this is our function. I mean, now we can find the derivative easily. So now the derivative dy by dx will be, so now we directly multiply by the coefficient of x. So now we have negative 2 times 1, which is negative 2 x, and here we subtract 1. I mean, always, just if you are not, sorry, that is okay, I already did it, but always if you are not sure, just say negative 2 minus 1. Okay, so plus, and then again here we would have, we multiply by the coefficient, so we have 2 times 2, which is 4, and then x to the power, we subtract 1, which we get x. So this is the final answer of the derivative. So, and now so there are some rules. So we already know that example 3. So if you have a function, any constant, let us say 3, so then in this case dy by dx is equal to 0, because the function is independent of x. Here we only have 3, so in this case we directly, this is equal to 0. So that means if you have or any constant, then that is directly equal to 0, and we showed this in the previous lessons using the limits. So you can also show this using the limits. This is already equal to 0. So again, now we introduce some rules of differentiation before we go further. For example, so let us say that, so let us call them just the rules of derivatives. Let us say that we have, say, we have two functions, or let us just maybe say y, if y is equal to f of x plus or minus g of x, is two functions. I mean that we already did it, but now we do the rules. So that will be dy by dx will be the derivative of the first function f of x with respect to x. So we differentiate with respect to x, then plus or minus g of x. So the derivative of g of x here, we can also do this. So with respect to x, so it's the first thing. 1, 2. If we have a function y is equal to some constant c, then the derivative dy by dx, because here y is independent of x, then we will say that this is equal to 0. So 3. If we have dy by dx, sorry, if we have y equal to k f of x, then we can say that dy by dx will be equal to k df of x divided by dx, divided by dx. So this is just a derivative operator. And now so of course we have more. So we have the multiplication, for example 4. If we have those two functions, if they are multiplied, so if we have f of x times g of x, and we would like to find the derivative of those two functions, so then we would have dy by dx, then that will be equal to, so the first function f of x times the derivative of the second function times the g of x divided by dx plus, so now the other way around, so we say the second functions times the derivative of the first function, so that means plus the second function times the derivative of the first function that we have with respect to x. So cool. And now we have the quotient, and we have many more, but now let us just stick to this rule. So just a simple example 3. So let us say that we have y that was equal to any two functions. Let us say, just to make it simple, so 1 plus x squared times 1 minus 2x cubed plus x squared. So here, of course, you can also multiply directly, but now the purpose here is we would like to use a multiplication rule of derivatives. So if you would like to find dy by dx, simply we say, okay, dy by dx, that will be equal to, so again, the first function, which is here, I mean, now we can say this is f of x, and now this is here u of x. We have two functions multiplied by each other. So the first function times the derivative of the second function. So we can just write the operator of the derivative as d by dx, and then we put the function here. So that is always recommended to do this. So then just, I mean, this is the first step before we differentiate. We just applying the rule. So, and then d of x, the second function, which is now 1 minus 2x cubed plus x squared, so times the derivative of the first function. So the derivative is d by dx for the first function, which is 1 plus x squared. Okay, so now let us continue, and now applying, now we take the derivative of those two functions. So we have 1 plus x squared, and then we multiply by the derivative. So the derivative of a constant is 0. Now here we multiply this 3 by -2, we get -6, and we subtract 1, so we get 2 here, and then plus, again we multiply 2 by the coefficient, which is 1, and then which is 2, the coefficient is 1 and the multiplication is 2, and then we have x, 2 minus 1 is 1. Now we finished from this plus. So now we just copy this here, 2x cubed plus x squared, and then times the derivative of this function. So the derivative of 1 is 0, you don't need it, and the derivative of x squared is just 2x. So, I mean, of course, you can do simple algebra, or, I mean, that is, until here, that is correct. That is the correct answer. So you get the full mark of this. So for this video, we stop here, and we will continue with more complex examples of derivatives and the applications of derivatives, and we will do some integration. Thank you very much for watching.